Hello and welcome back to Spoken Essays. I am Harshil Vora and you are watching the freeCodeCamp tutorial where we learn JavaScript algorithms and data structures. So let's continue without wasting more time and see where we were at. So let me set my system up quickly. I just wanted to be live as soon as I could, so that's why here I am. So just a second, guys. Okay, I'll try to do that. Okay, yeah, much better. Okay, you'll hear a few clicking sounds here and there. Nothing to worry about. Just me setting up a few things for my Facebook Live as well. And of course I adjusted my chair just a few seconds back. Okay, I think you guys can hear me pretty loudly, pretty clearly. Yes, you can. Okay, nice. I can see we already reached 1 like, so must be someone must have been waiting for that. Sorry about that. Next time we can maybe keep the time a little less, but you know how it goes with live, we never know. Let me start this. And guys, some interesting information for you guys to know. If you don't want to open YouTube in your own Chrome tab, you just want to keep OBS open, you can do that. The start streaming button itself starts the stream. You don't need anything as long as you've already filled all the data in the YouTube studio. So you really don't need the tab anyway. The stream will continue to go on. If you want me to cover that in one of the videos, I can surely do that. Of course, at the end of this week, we will also go over a few of our goals which we checked in the sheet. So we'll also do that. But until then, let us continue from where we left yesterday. So just a second. Now I can get the earphones. Oh my god, this is good. Yeah. So you guys might be wondering why I'm wearing white earphones now and not the black ones. The black ones simply hurt my jaw a lot whenever I sneezed, or after wearing buds for longer periods. It seemed that it hurt my ears a little bit. So I tried it for 3 weeks. I think it's already 4 weeks now. But the pain was too much, so now I've changed this to some weird white buds. Anyway. So let's get to you. Okay, much better. These one, of course, they don't fit as tightly as the black ones would, but these do the job. They just stay on the ear perfectly still, really. But yeah, okay. So first, okay, I'll share my screen with you guys so you can see what is happening. We are live on YouTube and Facebook. Great. Facebook. Actually, Facebook is already on. Aren't we live? We are live. Okay. I'll have to share my screen with you guys as well one time. Okay, you guys can see that. Amazing. I'll have to make this window active if I want to do anything to it. First I made it active. Now we are going to play with this. That is amazing the way Mac has done this. Yeah, so an active window has a different color. You can see the moment I change this. Keep your eyes around here. The moment I select a different window, the color will change. You saw that, right? Yeah, now it's a grayer shade. I have not clicked on anything yet, but the moment I click on this, the window will become darker. The window part will become darker. That's because of active windows, of course. Now we write freeCodeCamp. We go to freeCodeCamp.org. We go to basic JavaScript. We went through that. Collapse. Very good. I would have been scrolling non-stop for no reason. Oh, we have one viewer. Thank you for joining today. We were working on intermediate algorithm scripting. So far, I think we finished 8 courses according to FreeCodeCamp. We finished basic JavaScript, ES6. We finished regular expressions, debugging, basic data structures, basic algorithm scripting, object-oriented programming, where we learned more about classes and objects and how to map stuff, filter data, and so on and so forth. We have Swamijit with us. Morning, Swamijit. That is amazing. One of my viewers is always here. So tell me, Swamijit, how do you manage watching my videos and studying in college? Are you in college right now? If you are, yeah, let me know. Or if you're at home, of course, it must be vacation time, isn't it? Yeah, it's vacation time. So enjoy the morning. It is very pleasant indeed. Yeah, the weather is indeed pleasant. Okay, now we were at sum all primes. So we have to sum all the primes. Oh my god. Yeah, we were. Okay. So we're supposed to do this, aren't we? Right. I have no clue where I was from last night. I will have to read all of this again. So let's see. A prime number is a whole number greater than 1 with exactly 2 divisors greater than 1. So we started with 2. That's why we started with 2. I see it now. Greater than 1 with exactly 2 divisors. Only 2 divisors, 1 and itself. There are numbers with more divisors. Any number that is any composite number has more than 2 divisors, but only a prime number has 2 divisors. For example, 2 is a prime number because it is only divisible by 1 and 2. In contrast, 4 is not a prime since it is divisible by 1, 2 and 4. Pretty standard explanation, pretty clear explanation really. We can continue. Now it says rewrite sum primes. This is the function, so it returns the sum of all prime numbers that are less than or equal to sum. Pretty standard, pretty cool. To number, yeah. So we have to sum primes now. Instead of Fibonacci numbers, now we will work with primes. So I can write a similar loop. So let's see why I wrote 2 for loops and not 1, or why not 3. Why 2? Why I was stuck with this. So we have a function called sum primes. First it declares 2 variables called primes, which is an empty array, semicolon please, and a which has the value of 2. I think we are going to append this or push this really to this array. So we'll keep changing the value of 2, I believe. I think. Okay. So what does this for loop say? So for let h equals 2. Okay. So we're going to start with 2. Okay. H is less than number, which is this argument h plus plus. So it will iterate with value of 2. Value of h. So it will become 3 and then 4 and then 5 and then 6 and then 7 and then 8. Cool. For let v equals 2, v less than h. So I think this must be the number and this must be the function to find out all the what we can say factors. Yeah. So for loop let v equals 2, why does this say? Why should it be 2? It can't be 2 really. Why is it 2? Let v equals 2. Okay. But when the number is 3, will it only do it twice? How many? This should be 0 then. Let v equals 0, v less than 2. So it will iterate thrice. With each number it will keep iterating that number of times. Then we should write 1 then. I don't know, let's find out. Then v plus plus of course 0, 1, 2 and 3 and 4. So now we have an if loop. So basically it will iterate what number 2 into 10 till 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. What does this say? If number divided by v, so v divided by 2. This cannot be v then. I see we came up with something the last time, we didn't we? Let me copy this code then. Let me close that window, please. I'll close this window. Right, so this is where we were. Paste, please. I came up, I read this, looping through 1 to number. Check if number is a factor. So it says num I is equal to 0, so remainder 0. So that's how we find out something is a factor. Oh, achha. So this is how the way you wrote that code. I see. Number, yeah, if it's divisible by that number, then if the remainder is 0, then it is a factor. Right. That's why it should be 1 and not 0. I get it. Okay. Right, so v equals 1, and then you should not take num really, you should take h. It won't be an infinite loop. It will only run this n number of times, and this loop will only run h number of times. If h divided by this is equal to 0, yeah, we can use strict operators here. It's math. Right, then we can't do it here then. Have to seriously think about this. How do we get numbers with only 2 factors? I mean, this will put all the factors of each number. Let's say 1 to 5, right? So push. Wait, what are we even doing? This is only an iteration. If it's true, if it is a factor, then you do what? Push h, yeah. Primes dot push h. Prime is not defined because it's primes. And now we ask it to return primes now. So we have 2, 3, 4, 4. What is that? Same is the same. So 2. So this is the 2th iteration. If we have 0th iteration, inside the 0th iteration we have a for loop. For the number 2, yeah. We'll check 1 divided by 2, and then 2 divided by 2. So we have 2. Shouldn't we have 2 thrice? Or actually twice. So inside this for loop we will push the number 2 once. This is not the way to write code. I mean, to accomplish this, we'll have to get some help. I know it's only been 27 minutes, but I have to understand how to write this. I can't make heads and tails out of it. Heads and tails. You can use the definition of prime numbers. I will use that definition. Yeah, I think 6n plus 1 will help me out. Try learning and implementing your own sieve of Erasthenes. Okay. Eratosthenes. Sieve. Acha. Check this link to see a Stack Overflow discussion on various ways to find prime numbers. How to find prime numbers between 0 to 100. In JavaScript, how would I find prime numbers between 0 to 100? I've thought about it. I'm not sure how to find them. I thought about doing x divided by x, but I found the obvious problem with that. That is what I have. This is what I have so far. But unfortunately, it's the worst code ever. So someone wrote some long code, right? So 1 to 12. Actually, not 1 to 10. Yeah. So we need a something for this. If it can only ever be between 0 and probably just to find a list of prime numbers and make an array of them, then check index of number so on. Someone also came with this answer. This has been the most upvoted answer apparently. It says function get primes. Interesting. Is it ours called? Oh, it's some primes. Interesting. Okay. We have variable sieve. So something of I remember sieve now. Sieve of Eratosthenes. What is the sieve of Eratosthenes? Eratosthenes. Let's see. Name. Eratosthenes. Okay. In mathematics, the sieve of Eratosthenes is an ancient algorithm for finding all prime numbers up to any given limit. It does so by iteratively marking as composite the multiples of each prime, starting with the first prime number 2. The multiples of a given prime are generated as a sequence of numbers starting from that prime with constant difference between them that is equal to that prime. What does that mean? So we have 2, then 3. So that's 1. The difference between them is 1. Then we have 9. The difference between them is 5. So 1 and 5. What is that? Oh yeah, we also have 5 in here, 7 in here. So 1 and then 1 again. So 1, 1, 2. No, 3. 1, 1, 3. Oh, sorry. Yeah, 1, 2, 2. 1, 2, 2, 4. Oh, I think I thought of that. There is a better way then. Yeah, I have to read this then. It does so by iteratively marking as composite the multiples of each prime. Multiples of each prime. Let's look at this for example. So multiples of each prime, right? So it will mark multiples of each prime. So first it will finish 2 and then 3 and then 5 and then 7 and then 9. Right. Starting with the first prime number 2, the multiples of a given prime are generated as a sequence of numbers starting from that number with constant difference between them that is equal to that prime. Yeah. This is the Sieve's key distinction from using trial division to sequentially test each candidate number for divisibility by each prime. Once all multiples of each discovered prime have been marked as composites, the remaining unmarked ones are primes. Oh my god. So first 2 and then 3 and then 5. Which ones do we try to find out? We write 5, that is 2, 3, 5, 7. 9 is not 11. Let me check for 11 and 23. No, we don't even need to go to 23, do we? The earliest known reference to the sieve is in Nicomachus of Gerassa's Introduction to Arithmetic, an early 2nd century CE book which attributes it. Chrysler book which attributes it to Erasmus, the 3rd century BCE. Greek mathematician, though describing by the sieving by odd numbers instead of by primes. Odd numbers. Right, so 2, 3, 5, 7. Do you only do the steps? Let's see this. Prime rule 121. Come on. Okay. So first it marked all the multiples of 2. Then it took 3. Now it's marking all the multiples of 3. This is something very interesting. Oh, can you guys see that? I think, yeah, maybe I'll zoom in a little bit more. Much better. Now it marked all the multiples of 3. Now it will mark multiples of 5. And then multiples of 7. Oh, and the moment it's done, the rest are prime numbers. Very nice. Okay, a pattern is emerging in my mind. First we have to create an array. Yeah, we don't even need to do that, right? We only want. So what I'm thinking is we can create an array. That array will contain all the numbers less than the argument, which is this. So 10 के नीचे 1 से 9 for example. Yeah, so then we clear this out, sorry about that. Basically push each number. अभी तेरा कुछ काम नहीं है, I think. Okay, bye, that's it. Okay, so we have all the numbers that are less than a specific number, right? Very good. Now we have to filter the primes out. Pretty simple, pretty cool actually. Now I slowly get it. So instead of a for loop, what could we have used? I don't think anything. We have to, if we want to print something so at a large scale, then we have to do this, right? Less than or equal to, right? Less than or equal to number. So 10 is also a part of this. Although it's not a prime, but it should be there. Cool. Now that we have a loop that prints all the numbers that are less than this in an array, now we can get to work by filtering the data. This is where the sieve will come fall in place, but I have no idea how to write that code for that sieve yet. So let's think. Cool. So we'll have to write a for loop and then filter a for loop. We filter inside a for loop, but for now let us try to filter what? So let f array filtered arr be primes. So these are not primes anymore. You can write all the numbers. Yeah, that can stay there. Numbers dot push. Right. This looks like far and not f array. Filtered arr. Cool, filtered array now. So now that we have all the numbers that are less than or equal to 10, now we find out whether one number is a prime or not. Now I know why I used that for loop. Why I thought of using that for loop. Of course it had flaws, but yeah. Let's review this. Now maybe this will make more sense with the sieve. So it creates a global variable called sieve in it, and then interesting. A sieve is an array of 1, 2, 3, 4. What? Interesting. I, comma j, comma primes. So I think you're declaring various variables. One is called C, which is an empty array. Then I and j, which are that are undefined. We'll probably define them in the next subsequent steps. And then primes, which is also an empty array. When we have a for loop, we know. Oh yeah, we know one kind. We don't need to use one really. We're never going to use one anyway, right? So I is less than max. So max. Of course, we're also supposed to sum all of that, but we can use map to sum it. So I'm not worried about summing really. We want to find primes. First, we have to use a sieve to find primes. So max, right? Okay, whatever. We can really use any number really, but we won't need to go till then. But okay. Now inside we have an if loop. If sieve I, which is 2, if the second index value of sieve, what? I has not been marked, it is prime. Yeah, I is 2, right? So sieve I, which is 2, but when did you push it? Then primes dot push I, then you push 2 in here. Then inside this for loop, inside this if statement, we write another for loop. For j equals 1. Oh, I've never seen that character before. Strictly less than, if it's strictly less than 1, then you continue. Wait, you assign the value of strictly less than 1. J equals I, this double arrow 1. So you are assigning it. It cannot be a condition. You're assigning it the value of I less than 1. Strictly less than 1. So any value. What are you saying? When j equals max, when j plus equals I, so j equals j plus I, right? See, if get primes will return an array of all primes between 2 and 100 inclusive. Of course, due to memory constraint, you can't use this with large arguments. A Java implementation would look very similar. Then we have 60 upvotes. This must be the best answer, must be the shortest answer. And just like me, someone else didn't understand this in 2013. The double lesson of shift the left operand by 1 bit after converting it to integer if necessary. It's just a quick way to multiply by 2. Then a loop just okay. So it multiply inner loop multiply by 2, right? Now here's how I solved it. Rewrote in Java, revert from Java to JavaScript. So excuse me if there's syntax error. Oh, someone wrote this in Java. Wait, this is also JavaScript. Right, is prime. If n less than 2, then return false. Basically, yeah, okay. Right. Then we create a global variable called q, math.square root n. For, oh my god, we aren't even using math, are we? Math in JavaScript. Completely overlooked math. JavaScript math object. Thank you. Right, so we have Euler's number, pi. Euler's number just stored in a variable in an object called math. Very cool. Square root of 2, square root of 1 by 2, natural logarithm of 2, natural logarithm of 10, log 2, base 2, logarithm of e, base 10, logarithm of e. What other methods can we use? Math, round, sealing, round to the nearest integer, round it down to the nearest integer, truncate, returns the integer part of x. So if it's 4.5, it would return 4 or 5. Okay, math round, math ceiling, math floor value, yeah, sign. returns if x is negative, null or positive. Math power, square root, absolute, positive value, sine, cos, minimum and maximum. Oh, I can use that, and is an if statement. Math random, math.log, log2, log10, and we have more methods, right? I thought I could use maybe one of these from the math object, but I have no clue which one to use. Now to filter through an array, filter is in itself a loop, so whatever we write here can be written in this. What do we write? I need to understand this then. So it says math floor, then math.square root n. What is n? This number, square root of whatever number we are putting. An integer is prime if it is not divisible by any prime less than or equal to its. Oh, that's another tidbit for us. Sorry about that. The chair keeps. I keep sliding from the chair. An integer is prime. Okay, that's another way of finding out whether something is a prime. Some number is a prime number or not. An integer is prime for if it is not divisible by any prime less than or equal to its square root. Right, its square root. So let's take 3 for example. 3's square is 9. So 9. Let's take 9 for example. If it is not divisible by any prime less than or equal to its square root. Any prime less than. So we have, let's say, 9. No, not 9. Let's take a huge number. Let's take 11. 11's square root would be a weird number, but yeah, will less than or equal to its square root. Not divisible by any prime number. Okay. I don't get it. Maybe if I read the example, I'll understand what the sentence says. So variable q, we're storing something in a variable called q. What does it store? So we have math.floor. Floor will get us the round down value. Math.square root of n. So first let's take, if you take 11 for example, square root of 11 is whatever, and then it floors it down, so basically round downs. Then we run a for loop where the variable I is chosen as 2 because we are only working with values that are greater than 2. Then I less than or equals to q, which is this, any number that is less than or equal to the square root of a prime. Okay, I plus plus, so it will loop that number of times. If n divided by I equals 0, then you return false, otherwise return true. Right. So let's take I don't know, square root of 11, 3 point this, right? So this will return 3 for example. This will only loop once. It will only loop once because now I has become 3, but 3 I also 2. It will loop twice. It will iterate twice. So first it will check whether it is divisible by 2. It is, then return false. If it is, then you check 3. Oh wait, 3 is not. 2 is not. 2 won't return this, so you simply return true. It is but it says by any prime number. Okay. I don't know how I can apply this to my code then. What do we write in the function? We have the filter function doing the looping thing for us. I have to declare a variable with 2 for that. Won't I see. Let ABC equals 2. Cool. Now we can filter that data. Oh, I see. How will we factors of a positive number? Nope, we don't want factors. How did this guy do it? What was I thinking when I saw this? One way or another, I can close this. We are going to iterate through each value 2, 3, 4, 5, 6, 7, 8, 9, 10. What test do we run of it being a prime? How do we check whether a number is a prime? Only divisible by 1 and 2, right? So we have to find out each number's factors. If this thing has more than 2 factors, that cannot be it. There is a reason why this is very specific. It doesn't say if it only has 2 factors. Specific factors, right? 3 might, 5, 6 might only have 3 factors. Wait a minute. Let me think. So 6. We have 1, 2, 3 and 6. Those are 4 factors. 5, 1 and 5. 4. 1, 2 and 4. Okay, so I was spot on. Is there a math.factors function? I don't think so. Another way is this, of course, where you write 1 to whatever number, then you filter out all the multiples of 2, then you filter out all the multiples of 3, then you filter out all the multiples of 4. Yeah, okay. Except for the number 2. Except for the number itself. Right. Okay, let's try to filter out all the multiples of 2 then first. First we'll try to filter out all the multiples of 2. And that cannot be simply it. But let's see. So we are trying to filter what? Now we have a function for us. We write each item will be iterated. How? So you will check whether the item then 0. And I should write the opposite of that. Oh yeah, I'm sorry. I don't need to edit anything. I have to change you. Copy this. Now we only have multiples of 2. So instead, I want to filter out. I don't need to write 2 then. I can use a for loop for this. Right. No, can't. We don't know the pattern for multiplication. Or yeah, for each number. I'm thinking maybe we can make an array. With this we know that we only need to find out the multiples of 2, 4, 5, 2, 3, 5 and 7. Only the multiples of 2, 3, 5 and 7. The rest can be weeded out. But we have to keep 2 in this. How do we keep 2 and not let it go there? One thing I know is any number less than 2 will have, one thing we can do is I can keep 2 in here. Yeah, so it will still be filtered out, won't it? I did write something similar yesterday. I wrote if index value has index value, then only then you filter it out. Maybe we can use that in here. So if right, an if statement is invalid unless we wrap it. Is the same to me, but you wonder. Should you have one day close it to this way, should we? Maybe we can't use the arrow function because this is meant to return a value. Then in that case we will call it a function. Eerie, skating shooter, never seem to find the time. There's something I'm saying. Again. I like to be here when I can. Then why can't we use you? Is my question now that we have the semicolons. Oh, sorry. Right. Oh, we can write it this way. Very good. This is an anonymous function which takes an item. So first we'll check with each item. Oh yeah, right. We can't write filtered array yet. NUMBERS. Each number. If item divided by 2 is 0, then you do this. Oh. Okay. There's no point in writing an if statement. Why did I think of writing an if statement? Maybe I can make this an array of 2, 3, 5, 7. Filter all multiples of 2, 3, 5, 7. Maybe. Okay. Let's think of that. 2, 3, 5, and 7. That's an array now. Now we run a for loop, and inside a for loop we run a filter. For this. And where does this loop end? Should be here. Alright, as my friend likes to say. Now we write let what? I be 0. I should run this many times. So 2, 3, 5, and 7. Filter out all 2, 3, 5, and 7 numbers. Multiples of 2, 3, 5, and 7. Till the number. So if we have, for example, oh yeah, let me finish this. Then I'll explain. Okay. abc.length. And then we write I plus plus. Basically a for loop which filters through each. Yeah, you guys get it. Numbers will become the filtered thing itself. Numbers equal numbers dot filter, right? Then we don't need an if statement here. Shorter of breath and one day closer to death. Every year is getting shorter, never seems to find the time. Right. ये क्या करता है? Numbers को rename करता है in this for loop. Now we make this ABCI. Right. Now we don't have any numbers left. It's only 10. Can't seem to do that, can we? I did think of something. Where did my if statement go again? Push. Filter only if the. How will it know if it's in multiple? Oh yeah, we wrote that, didn't we? Right. First you check each number whether it's divisible by 2, then you check each number whether it's divisible by 3, then 4, and then 3, 5 and 7. Right. We can't use index value because each thing's index value will be different and their value will be different. What rule do we put to not filter them? Maybe we can use map or reduce. No, we don't need reduce. Reduces it to one function. We're not mapping anything. Are we mapping anything? Think what shortcut we can use or what trick are we supposed to do that will help us avoid any number that is less than 7. Right. Oh, then you don't filter that. Yeah. If a number is less than 7, then you don't filter it. So we'll filter out all the numbers that are multiples of those numbers but are not those numbers. Right. Okay. Now I'm getting. Use the line break, please. Now inside this we will write a for loop. Sorry, not a for loop, we'll write an if statement. So first curly bracket open, curly bracket close, inside 2 more curly brackets. I write if statement here, if statements, this thing, oh yeah, this can cut itself and it will be put in here. Now we write the if condition. If item is greater than 7, then you do this, otherwise do nothing. What does this do really? If the items, with each iteration it will change a number, right? Maybe if it was easier if we like it here, filter equals multi-array, then we can access it. So what does this do? Numbers.filter, and then it runs an anonymous function with item. It runs an if statement. If item, let's say 2, is greater than 7, which it is not, it is false, then you do nothing to it? No. We ask it to return true. We don't need return, we simply write true, don't we? Okay. maybe let's see. Filtered array first. Right. Maybe I can write greater than 7, any number 8, 9, 10, 11. So 8 should be filtered out. If item, let's say 2, so is 2 greater than 7? No, it is not. So we ask it to return true. Is 8 greater than 7? Yes, then you do this. Oh, right. Think. How do we get it to not filter numbers? The sun is the same in a relative way, but you're shorter of breath and one day closer to death. Right. Every year is getting shorter, never seem to find the time. Oh my god, we also have 4. Maybe we can simply use these tests in this for loop itself. I completely forgot, overlooked 4 and 6. I did. Completely overlooked. Can't write it this way then. Yeah, oh, we have this with us, don't we? Oh my god. ABC I. Oh. It will only return 2. It will only return 7, I get it. Because with each iteration, the number will change. I love this challenge. So in our journey to preserve this, I mean, if we map it, it would work, but we're not mapping anything. We're only filtering this data. I want to filter and store all the primes. If for loop returns more than 2 numbers, 2 factors, I keep going back to those factors. How do we write it without finding out factors? Finding out factors is a troublesome work, even a computational nightmare. Why? Because each computer would iterate through every number till it's asked. Well, it's supposed to do that, but what can we write instead? Maybe this is more painful for it. Yeah, as if that would do anything. So why does it return only 7 and not 2, 3, 5 and 7? Let's think about that for a minute. Because it resets itself, doesn't it, in the for loop? It is filtered array, so it stores these values. So with each iteration, the value would change. How about now? Yeah, okay. I have to write numbers equals numbers not. It's the same thing really, it will return an empty array, not even 7 now. If it's any of them, just don't do anything. If the first three countries are any of them, just don't do anything. Oh yeah, what can we do? With each iteration it will still be filtered out anyway. Can I do that? Instead of assigning it a value, what if I have push shorter of breath in one day, closer to death. So we have 2, 3, 5, 7. Let's get more numbers there. 9, 7, 7, right? Yeah, stops. Why stop that? Push all the filtered data out, then we don't need this. Wait. Check 2, 3, 5 and 7. If any prime number is divisible by that, then we return this. Oh baapre. I can't write this. Won't work, simply won't work. But now we don't have to, we have 3, 5, 7, 9 and whatever. And then we have another set of 2, 3, 5, 7, 9. Because of the for loop. Why is this not 2, 4, 5, 7? Then we have 2, 3, 4, 6, 7, 8, 9. Yeah, this is a nightmare. Because each of them will return a separate array. Won't push anything. Why is this filtered array not? Well, it is 98 is gone, so I think multiples of 2 are gone. No, they're not. I see 7 has disappeared. 7, why has 7 disappeared? If item, let's say, right, if we remove this, can't. Print numbers, please. Yeah, so this is what numbers looks like. We have 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. What would this filter array do? Filter array numbers ये क्यों है? निकालो इसको. Right. नंबर्स डोंट फिल्टर, तो इसको भी फिल्टर लगाएंगे क्या? हर एक आइटम को चेक करो क्या वो आइटम 2 के साथ डिविजिबल है. If it's not equal to 0, then you return false. If it is equal to 0, then you return true. If it returns true, then it gets filtered. Oh my god. Yeah, अभी उल्टा हो गया. Okay. But wait, we do want to remove all multiples of 2. Wait. दिखा तो मुझे फिर से, अभी थोड़ा समझ आया. So now we don't have multiples of 2, but we have 7. 7 went away, 14 went away. How did it only filter 14? Now it only shows me multiples of 14. Because 7 is the last of the yeah. It filtered out all 7 things. Yeah, because we're running a for loop. Oh, I see. Why did I run a for loop? Because of you. 2, 3, 5 and 7. Remove all the multiples of 2, 3, 5 and 7. Shut off Monday class today. Keep coming back to that. Oh yeah. I is not defined. Yeah, it's not defined. So now it is removed 2 and all multiples of 2. I could use that. No. So now what disappeared? Nothing. And ampersand. Right, so 2, 4, 5, 6 disappeared, multiples of 2 have disappeared. Now it's time for multiples of 5 to disappear. Then instead of using an array here, doesn't matter really. We're slowly filtering everything out, aren't we? 3. Marvelous. So 0, 1, 2 and 3. So now we have AV prime after 7 until 100. Okay. God. These are extra steps, aren't they? Now I have to unshift 2, 3, 5 and 7. Summing will be easy. You have to item plus 1. I think now we have all the primes we need. Is 89 a prime? I wouldn't know. Okay. Yeah, this will keep going on and on, right? Oh. Ten will return an empty array. I know why. Okay now. Yay, we can unshift to no. ABC. This is really an extra step. I wish I hadn't done this, but I'm doing it. Right. What? After it has been filtered, what are you? What? Oh, right. Can't do this. I'm reassigning it. I'm done. Come on. Come on, Zed, come on, Zed. What is your problem, man? Oh, acha, oh, it doesn't have a problem. Nice. But we also have to return a sum, don't we? Can't push it. We have to unshift it. Yeah, the moment I write 100 now. 2357 and then this and that. Okay, very good. Now I want to do some of these values. We're going to use map for that, aren't we? B equals B dot map. Nope, reduce to sum all of them. Sum equals sum plus, I think A plus B should do it. A and B. A comma B. A plus B. Why not? Right. Comment you again. What does B return, by the way? It returns 4. We can't reduce B then. Then what use are you even? No? Okay. so funny. It returns 17. I think that's right. Yep, I think we've passed it. But of course the code is not simply complete. Yeah, 977, it will die. What does it return? Let's see. No, it won't die. It will give us an incorrect output. It says 108789. This is 7. Excuse me. This says 1,08,000. This says 73,000. You've ended 30. Okay. Why? That doesn't do anything. Can't write code this way then. Oh yeah, that whale is only for numbers till 102. The rules might change when the numbers change. Didn't think of that, did ya? Can't only do it till then. All multiples have to be not only all multiples of 2, 3, 5, 7, but more. We simply can't do that. I see the problem. Let's read the next part of the hint. Prime numbers, definition of trial learning or implementing your own sieve. Check this link to see a Stack Overflow discussion on various ways of finding prime numbers. This problem can be hard if you create your own code to check for primes. Yup. So don't feel bad if you use someone else's algorithm for that part. Research is an important part of coding. Right. Why don't I just copy the solution? Right. क्या बताता है भाई? Nope. चलो sieve बनाते हैं. Maybe not. I don't understand any or all of this. I mean, it's an opportunity for me to understand any or all of this, but some other time. Basically, this will replace everything except for reduce. We will reduce everything still. Comments are not required. Thank you. Wow. Look at that spacing, man. The code does look neat actually, but what can we say? Oh, sorry. Z, yeah. Oh, yeah, we need that, don't we? Shelter of breath, and one day closer to death. Keep singing that song. I love that song. Yeah, this was better anyway. Okay. Right. N is not defined. If n, what is n? N is num. Yeah, I'm not going to use that if statement. We know variable q, MATLAB floor. This will become num square. Oh, right. An array. Yup, we need this. Come on. I don't understand that. Live demo of the script. Okay, bye. Is prime, whether a number is prime or not. No. sieve of what? Sundaram algorithm to cut the necessary iterations, and it seems to be very fast. Interesting. Sieve of Sundaram is the same thing, but looks faster, unoptimized. Okay, maybe some next time we can revisit this. Dupe. Someone can also run this code. I am going to use the most upvoted answer, and then we can tweak it. Y till 100. Get primes and will return an array. Of course, due to memory constraints, you can't use this with large arguments. Java implementation would look very similar. Okay, so instead of this, then we now try U. Yeah, okay. We have a global variable called C, which is an empty array, then I, and then J, and then primes. Cool. Max will become number. Oh. Max will become number. Yeah, now we have 2, 3, 5, 7, 11, 23, 19 till this whatever. And interesting. Okay. How is the question now? So we have a for loop, I equals 2, so it will begin with 2. Is I less than or greater than less than or equal to the number? Yes, it is. Why is plus behind it and not after it? They're the same thing. Okay. I plus 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 I plus plus. Okay. So now inside this you have an if statement. If, what does this mean? Save the ith value, which is 2, but we don't have any value yet. Isn't. What does this mean? Isn't. I has not been marked, it is prime. Huh? Huh? What? Think again, let's think again what they're doing. I has been defined as 2, so save second value. Now right now it's an empty array, so not empty. Huh? Huh? I want to see this printed out. What does this? I love my hairs, don't I? Yeah. Okay. So this thing returns true. So save 2. What does this mean? What do you mean? Okay, chalo, ye dikha bhai, chalo. Undefined. If it is not undefined, interesting. What are you doing, my friend? Okay, so with some condition, you're checking some condition. Let's think, yeah. With some condition, with each iteration, this will go on till here. So, right, for loop, and you'll only push that value which is a prime. So you write primes dot push I. It has something to do with this. But what? Yeah, we can sum it. Yeah, summing is not a problem. What are you doing, my friend? Let's think of this. I has not been marked. It is prime. Yeah. Why does this return this then? It will return an empty array. Oh, we have Mr. Abdul Malik again. Hello, Mr. Abdul. Is that louder? Is it loud enough? Clear enough? How about now? Oh, you can hear everything really. This would simply return the position. I have to find out. Up operator in JavaScript. All the operators. Command F not equal to, right? But we're not using the not equal to, we're only using an exclamation first to logical not, right? If a number is not the second value of this, ith value of this, what are you comparing me with? If it is not the second value, let's say, okay, we have an array, right now it's empty, so this will return undefined. So if it is not undefined, then you do this, okay, but it is in fact undefined. It's an empty array, it would return undefined. Okay, maybe that's what. No, wait a second. Where does this if statement end? Here. Huh. You're not even pushing anything to the sieve. Huh? What does this mean? If it is not undefined, if sieve, the second value of an empty array sieve is not defined, it can never be not defined. What? If something is not defined, how does this return a boolean value, true or false? Let's think again. What does this say? Logical not and or not, bitwise. Okay. This is a type operator, logical operator. Fully described. Yes, please. Not x equals y is true. The not operator returns true or false statements and false, true for false statements and false for true statements. So this would return, of course, undefined. This would obviously return undefined because this is an empty array. Empty arrays are not printed, they are undefined. Why? Because there is no second value of this, or the third value, or the fourth, or the fifth, or the sixth, or the seventh, or whatever. It says simply what? So I think another way to write this is, if this is not undefined. I have no clue why they wrote this. Why is it not pushing number 4? 4 will also be undefined. Wait. What does this do? For j equals I. Okay. Another operator. I have to read that. Can you explain the JavaScript documentation there? It's not bubble vertical on ad hoc. This operator shifts the left operand left by 1 bit after